Welcome to our quantum deep dive. Today, we're diving into an explainer based on some fantastic work by Jorg O. A. Schneppet, and we're going to tackle a question that really underpins our very existence. Okay, let's start with a puzzle, a big one. It's at the heart of literally everything you can see and touch. So, you know how every single atom has a nucleus, right? Well, that nucleus is jam-packed with positively charged protons, and if you remember anything from physics class, you know that like charges repel. These protons should be pushing each other apart with this immense force. So, what's stopping them? What's the cosmic superglue holding it all together? I mean, really, what stops us from just flying apart?
So today, we're going to go on a little journey to unravel this whole mystery. We'll start with the universe's strongest glue, then we'll get to know the anti-pion itself. After that, we'll join the hunt for this ghost-like particle, see how it's being used as a weapon against cancer, which is amazing, and finally, we'll look at the secrets it's still waiting to uncover. Well, the answer is a force so powerful that physicists just called it the strong nuclear force. No messing around with fancy names. It's the undisputed heavyweight champion of all the forces in nature. But there's a catch. It only works over incredibly tiny distances. So don't think of it like a magnet pulling things together from afar. It's more like a constant, frantic game of catch. You've got protons and neutrons just chucking these tiny messenger particles back and forth over and over. And it's that exchange, that game of catch, that binds them together in this unbreakable grip. And, one of the most vital players in this cosmic game of catch is the particle we're talking about today, the Anti-Pion. It's this fleeting, kinda exotic piece of antimatter. But without it, that whole conversation holding the nucleus together, it would just go silent. The game would stop. So yeah, it's a true cornerstone of particle physics. It's the invisible glue holding our world together. Okay, so what is an anti-pion exactly? I mean, what's it made of? To really get to know this powerful little messenger, we've got to pop the hood and look at its fundamental building blocks. All right, so antipions belong to this family called mesons. And what's really cool about mesons is that they're not fundamental particles like an electron is. Nope, they're composite. They're actually made of a quark and its antimatter twin, an antiquark, just stuck together. So if you look at a regular positive pion, it's made of one up quark and one anti-down quark. But the negative antipion, our star player today, it's the perfect mirror image. It's one down quark paired up with an anti-up quark. See? Total opposites. So that basically lays out the whole pion family for you. You've got the positive one, our negative antipion, and a neutral version too. And here's what's just fascinating to me. The positive pion and the negative antipion, they have the exact same mass. I mean, down to the last decimal point. And that's not just some weird coincidence. There's this deep, fundamental rule in physics called the CPT theorem, and it basically demands that a particle and its antiparticle have to be perfect mirror images, mass, lifespan, the whole deal. Now, the neutral pion is the odd one out here. It's a little bit lighter, and get this, it's its own antiparticle. How weird is that? Okay, think about this for a second. If this particle is so crucial for holding our world together, but it disappears in a fraction of a second, how on earth did we ever find it? It's like trying to catch smoke. Well, its discovery is this fantastic detective story, a perfect mix of just bold imagination and some truly brilliant lab work. So the hunt actually began back in 1935, and it didn't start in a lab, it started purely in the mind of a physicist named Hideki Yukawa. He did the math and basically said, hey, there has to be some new massive particle out there carrying the strong force. But for 12 years, that's all it was, a ghost in an equation. And then in 1947, a team led by Cecil Powell actually found its footprints. They went high up into the mountains and used these special photographic plates to capture the faint tracks left by cosmic rays showering down on Earth. And there it was, the pion. It was a stunning discovery, and it earned Powell a Nobel Prize. And by the 1950s, we weren't just waiting around for them to fall from the sky anymore. We were making our own pions and antipions in giant particle accelerators, proving they were real beyond any shadow of a doubt. So we've gone from a ghost in an equation to a real particle. But the story takes an even more incredible turn. The antipion didn't just stay in the textbooks of theoretical physics. Oh no. Today, this fundamental little particle has a remarkable and life-saving mission. It's fighting cancer. Yeah, it's a process called pion therapy, and it basically uses antipions as these tiny, microscopic smart bombs. It's amazing. First, scientists create them and accelerate them to really high speeds. Then, they aim this beam of particles with pinpoint precision right at a tumor.
The antipions just zip through the patient's healthy tissue and then stop right inside the target. And that's when the magic happens. They get captured by the atoms in the cancer cells and, poof, they annihilate. They release this devastating, super-localized burst of energy that just shreds the tumor from the inside out. And this right here is the antipion's medical superpower. Think about conventional X-rays, right? They just blast energy from the moment they enter your body, hitting healthy tissue all along the way. But antipions are stealthy. They're like these microscopic cruise missiles. They travel through healthy tissue, causing almost no destruction, saving up all their destructive power for one final massive burst, right at the target. That explosive finish even has a name. It's called the Bragg peak. And the result is exactly what you want: maximum damage to the cancer and minimal collateral damage to everything around it. It's just brilliant. But believe it or not, its mission isn't over. I mean, beyond the hospital, the Anti-Pion is still an absolutely crucial tool for scientists on the frontier, helping them probe the deepest, most profound secrets of the cosmos. So by studying these antipions with just incredible precision, physicists are hunting for answers to some of the biggest questions you can imagine, like, is the universe really perfectly symmetrical between matter and antimatter, or are there tiny little flaws? Because finding one of those flaws could finally explain the ultimate question: why we live in a universe made of matter at all? Or could these tiny particles point us toward entirely new forces or particles we never even knew existed? You see, the Anti-Pion is like a key that could unlock the entire next chapter of physics. And that quote really illustrates the stakes here. I mean, if we find even the tiniest, most subtle difference between a pion and an antipion, maybe a tiny difference in mass or lifespan that just isn't supposed to be there, well, that wouldn't just be a small correction in a textbook. No way. It would be a revolution. It would be like a giant, flashing neon signpost pointing us toward a whole new landscape of physics that we don't even know about yet. So when you step back and look at it, the journey of the Anti-Pion is just, it's extraordinary, isn't it? It started as a pure idea, just a thought experiment to solve a puzzle inside the atom. Then it was discovered as this faint little track from deep space. And now it's been harnessed as a precision tool to save lives and to search for the next great breakthrough in physics. It is the perfect example of how the absolute smallest things in our universe can have the most profound, the biggest impact on our world. Well, thank you so much for joining us for this quantum deep dive. We really hope this explainer has illuminated the incredible world of the Anti-Pion for you. And if you want to take a deeper dive, please check out the original essay by Jörg Schneepatt. You can find more at schneepatt.de. Thanks for listening, and goodbye.
Schneepatt.de is a private project by Jörg Schneepatt dedicated to promoting quantum technology. Its mission is to present knowledge in a way that is clear, precise, and transparent for those just starting out, as well as for experts who wish to deepen their expertise. He firmly believes that education and access to well-structured information are the keys to unlocking the full potential of this future technology. If his work helps you realize your own visions and actively and consciously shape quantum technology, then the goal of his project has been achieved.